This is the slide that no one likes but me. This is just, my intro slide. He did a great intro for me anyway, so I don't need to go on about it. But I've done a book, so, buy it, please. Yes, we were promised cats, pretty cute cats, as Johan referred to. But I also want to remind you that not all cats are cute. Some of them look like this, and they've got their brains on the outside. So hope no one's eating their dinner. So how should you use this talk then? It's not to just be followed blindly. Software often is about trade-offs and decision making, and these decisions are yours to make as a team. So it's really about trying things and see what fits. And if things don't fit, then it's okay. Hopefully there's still some useful stuff anyway. So I tend to choose things for maintainability, for glanceability. I think there are some principles which make better code because it's easier to maintain. We spend a lot of time obsessed with how long something's going to take to deliver the first time. And we don't think necessarily always about what the cost of maintaining that code is. And if you think about successful projects, you have to maintain code sometimes for a long time. So maintainability, glanceability, I call it, how quickly you can glance at something and get a sense of either where you need to go or, what's going on. And then you hear this in Go a lot. Code needs to be boring and very clear. And also kind of self-similar. So if you've made a decision for a particular code base, it's nice if you have some consistency. It sort of saves you. And again, sometimes you break that rule for good reasons too. So the first thing I want to talk about is this tiny main abstraction that I do. I do this for any kind of Go things I'm writing, actually. And the reason for this is because I like to return errors. And if you're doing a lot of setup in main, you can't return errors from main. You have to do something like handle the error, whether you're exiting or however you're dealing with it. You have to do it again and again. So this tiny little abstraction, just putting run into its own place, gives you the ability, you can return errors, you can use defer, you can use the things in Go that we like to use. So that's a nice little tip, I think. I tend to have a server struct where I store the dependencies for everything. So a server, if I've got like a greeter service, I would have a greeter server that's going to do the work here. And the nice thing is these fields are fields inside the struct. They're not in global state. So this has quite a lot of benefits, actually. And I'll talk about some of them as we go. I don't generally like constructors in Go because they can hide what's going on a little bit. But I always end up with a constructor when I'm writing these kinds of services. And that's because I usually want to do some things that have to happen every time, like set up the routes in this case. But it's important not to set up dependencies in here because one of the value props of having this server type is testability. We'll come on to that more later. But you don't want to set up your real dependencies because you may want to use fake dependencies instead. If there is a dependency that you always need, you can, it's just Go code. You can just take arguments. To make this server work in an HTTP context in Go, all you have to do is add this serve HTTP method. And probably most of you have seen this by now. We definitely see it a lot. It's all over the place when you're doing HTTP with Go. And it's really all you need. You've got the response writer for writing the response, and you've got the HTTP request, which is kind of describes everything about the incoming request. And the tip here is don't do anything more than just kind of pass your execution to the router or to whatever it is that's going to be actually doing the work. Because it's an unusual place to, you wouldn't expect things to happen in here. This is really just to make it so that the server works. I have a routes.go file, and And I got this from Ruby actually. Essentially, all the roots for the service goes in one file. And, some people like to break functionality out into different packages and things. I tend not to do that, certainly in the beginning. But even if you're doing that, having a single place where all your roots are is a very quick way to find what you're looking for. Because often if you've got a bug report, or if somebody's, or if you're going to look at changing some behavior, we do tend to think of it as APIs, as from the URL's point of view. So this turns out to be a great way to not only see a map of your service, but also find the bit you need, and you can jump straight to the particular handler. So this is very nice maintainability boost. The handlers themselves are methods that hang off the server. And this is how you access those dependencies. This is just normal Go code. So there's nothing kind of magic going on here. It's just a method on the server type. And so, of course, you can access dependencies there. There is a point about if you have to make sure that you are safe with your code here, because if you've got some data in that server and multiple handlers are hit at the same time, or even the same handlers hit at the same time, you can get into sort of data race conditions. So you have to remember that this is a concurrent environment. Every HTTP request is its own Go routine. So you have to be careful with that, but otherwise it's quite hard to get this wrong. And most dependencies will be kind of concurrent safe anyway, so it's probably okay, but it's worth bearing in mind. I name these handler methods like this with a kind of slightly unnatural way of describing them, but you get the benefit, of course, once they're sorted alphabetically. They group up naturally, which is quite nice. So handle tasks create, handle tasks done. I like to just if I wasn't worried about that, I would say handle. Probably would say handle tasks done, handle login, handle log out. You could imagine others that are also auth related that you would have different names, and you don't want them to be scattered around. Because we're going to use them in the IDEs, and you get the little autocompletes, which is cool. So my handlers aren't actually themselves handlers; they return the handlers, and this creates a little closured environment that's specific to each handler. So this is very useful if you have handler-specific dependencies that you have to set up ahead of time. You can see here that we create this thing, and in the little handler, we're able to use that thing. And it's also very clear that, we could put that thing in the server type, but then you'd expect other handlers to also be using it. So in a way, this is a nice little bit of storytelling. You get to see that it's only possible that this could be handled within this handler. And so that's nice. Anytime you get to kind of leave clues in the code, helps with that maintainability. If you have any arguments that are handler specific, you can take them in as arguments. So in this case, we've got this format string, and you can see that in the roots down here at the bottom, I'm using the same handler, but with different input. So I've in this case, a different format string. And that can be very useful. Again, it's very clear. And it also means that you don't get this greeting handler until you pass a format string. You have to pass a format string in, otherwise the compiler is going to complain. So that's very nice kind of compile help for when it comes to actually using these handlers. And here's some more examples where you could see, and these are real examples that I've used things like this before. One that's quite interesting is passing in the rand for random numbers. So if your handler is working with random numbers, if you take the rand in as an argument, when you write test code, you can control the seed. You can pass in a predictable random number. generator. And that might help you test. Although Roberto Clapis points out that if in production you're using random numbers, in tests you should use random numbers too. But that's up to you. Either way, you don't get this random quote generator without giving it the random number generator. So again, type safety, compile time checks. By the way, feel free to interrupt if you have any questions. Otherwise, I'm going to kind of just plow through this. Okay. So I ended up preferring handler func over handler. This one's slightly controversial, but you see, if you haven't seen the distinction between these, it's worth checking out for any beginners. It's very cool because essentially the HTTP handler interface has that serve HTTP method on it. And then there's this function type called handler func, which implements that interface. So it's a function that implements an interface and has a method on it. And that method just calls itself. It just calls the function. And so the net result is you're allowed to just use a function instead of creating a full type when you want a handler. So that it's such a nice little, it's a nice little bit of design, I think. And that's why I like handler funcs. Sometimes if you're using third-party packages, they'll only provide the handler one. And then you have to do a little bit of marshalling between types, or a bit of typecasting to make it work. But it's quite easy to do. So really, it's just whatever's easier to read. And in my case, handler func ended up being easier to read a lot. So the middleware then become just normal Go functions that take in these handler functions and return new ones. And in this kind of decorator pattern, you get to run code before and after the handler, and maybe even not call the handler at all. So in this case, if that current user is not an admin, we just do not found and then we return. And then only if it is an admin will it fall through and call the original handler. And there's lots of use cases for this pattern. It turns out to be pretty powerful and very easy to read, and you get the type safety too. What's not to like? So I wire middleware up generally in that roots.go file, which again is a very nice way to map out the services. And for things like if something's admin only, like this middleware that I just showed you, you can see it in the roots, so it's very nice. You're almost describing the kind of properties of your API, which I think is nice. It's quite a nice way to do it. And it's quite clear what's happening, I think, too. So often we're dealing with data, and I'm very excited for Johann's talk, about protobuf or the binary protocols and things like this. And these ideas apply kind of, the ideas apply across the board. So it's quite useful to think about these things. I'll do this. I'll create a respond helper. I try not to abstract too much these days in code. I kind of used to abstract everything all the time, and then you tie yourselves up in some strange meta knots that are weird. And so I try now not to do that very much, but in this case it makes sense. So we have this respond method, and it takes in the response writer and the request. It takes in some data and a status code, and maybe all it's doing is just using the JSON encoder initially, and then maybe later you'll add other things. But that's the key point. When you want to support different formats, you have one place where you can go and change this. The same applies for even doing things like deciding whether to do a Marshall indent for pretty output or not. You could add that here, and then all of your endpoints will get it for free. And again, it's type safe. And I do the same for decode. And often, and sometimes it remains this way forever, I'll just be wrapping the decoder in some way. But again, you have the opportunity later to decode data in different ways, and this can be it can be very useful to make some progress. You want to maybe only support JSON in the beginning, but later you know that there might be more sophisticated or different interactions, and so you have an opportunity to do this. You can also do things like in this respond case, we have access to the request, so we could check that request accept header, for example, to see what the client is asking for. And again, you sort of only have to deal with that all in one place. If you build helpers yourself, then I would say always take the response writer and the request, even if you don't use them initially. Like in this case, look, we don't use the response writer here when I'm decoding. But what happens if you take them both, you're kind of future-proofing the API, and it's only 2 arguments. So, it's not like you're trying to save yourself from all possible cases in the future. These are really the only 2 types you need in order to be useful. So that's the tip. It's always take the response writer and the HTTP request, and that way it becomes familiar across the code base and it future-proofs the APIs. Sometimes I want sometimes we have request response objects, and by default, I think people would put those as structs in the package space, which is totally fine, especially if you're using them in multiple places. But if they are specific only to one handler, they can actually go inside the handler little environment itself, and they're only useful here. So the advantage is it declutters the package space. It's very easy to find because they're right there in the same function as the logic to then implement the handler. And you don't have to keep innovating new names for these objects. And handle greet might end up with greet request, greet response. If you've got lots of handlers, you can have lots of extra stuff that you may not need. And the other thing is, so you can just call them request and response every time. So it's very nice. That becomes the kind of pattern you get to repeat. Sync once is a pretty awesome API, actually. You just pass it, you create one, you instantiate a sync once, and then you call do and pass in a function. And it will guarantee that will only be called once. Now, if you think about, remember that every HTTP request is its own Go routine, then you could have 2 requests hitting the same thing at the same time, and you don't want to do the setup, and tread on each other's toes, and especially if you've got shared data, like in this case. So sync once protects you there, because what happens is whichever is the first request, that will trigger the function. Everything else will wait until that function's finished, and then they'll all continue. And you can in this case, I'm setting up a template, I'm parsing some files, so you can do that setup there. It has the added benefit of if this particular handler is never hit, then this work is never done. So you get to potentially make a saving even. But of course, the first time it's hit, it's going to take a bit longer, but it's got a bit of work to do. So this one really depends on your deployment model, or the situation in which the environment that it runs. Because, for example, on App Engine, you scale down to 0 your instances when no one's hitting your APIs. And so when you then get another request, that first request, it's then going to it may do a lot of work to set up all the handlers, which you might not want. Whereas if you think about a situation where you have long-running services, they spin up once and they stay running, then maybe you'd rather get all the work done and out the way up front, and then your services are all ready. So that's a choice you get to make. But this is a really nice little simple way to do it. And also it's cool that we get to have variables that are just inside this this handler only. Again, can't really access, you can't access them elsewhere. So, it's safer, clearer. Testing is very important, and the HTTP test package is pretty good. It has to be said. It gives you types like this. You can create a new request, which is a real HTTP request object that you're going to use. It has a response recorder type that lets you, you pass that into the handler, and it will record what is written to that response writer. The response writer is an IO writer. So by default, you can't capture that. It gets written like as a stream and then it's gone. The response recorder lets you in your test code capture that and save it. And there's a server type as well. So they make it really easy to actually make a real HTTP server run in your test code. It gets a real port and everything. And then you can make HTTP requests to it. So here's an example where we create the server. You can see I'm connecting here to a test database and setting that as a dependency. So again, remember, you wouldn't do the database connection work inside that new server constructor, because in this case, we don't want it to connect to a real database. We want it to connect to this test database. We defer the cleanup, of course. And then look, I'm making an HTTP request using HTTP test new request. And I make the response recorder, and then I just call that serve HTTP method. It's it's just normal Go code. There isn't a great deal of magic going on here. It's just like calling functions and methods, which it's quite simple to do and we're quite used to. And then you can make assertions on that response recorder, like it tells you what the status code is. There's a body in there as well, which is a bytes buffer. So you can access that. You can see what was written out and make sure that you're happy with it in your test code. You also get to only set the dependencies you're going to use as well. So again, there's a little bit of storytelling. If you had a test for each of your handlers, then you can see at a glance what that handler needs in this case, which can be quite useful. If you've trapped your request response objects inside the handler, that means they're not in the package space, which means they're not available to test code. So that seems like a deal breaker, except when you realize actually you can just create another one. And again, it's a storytelling opportunity, because in this case, I'm calling some endpoint, the greet endpoint, and I may be passing in this person object, let's say, that has lots of information that I could add, like maybe address and date of birth and all kinds of things. But maybe this particular handler only cares about the name. And so you can create a struct, an anonymous struct, immediately instantiate it, write that to a buffer with JSON, if you like, and then make a request with it. And it's clear that then this this greet endpoint is only interested in the name. It's not interested in anything else. So this means that tests become really useful for learning about how to actually use the endpoints in a way like how unit tests do with normal methods and functions. You set up you have some data, you're just going to pass it in and check what comes out. That sort of transactional thing, it's the same. And it's very easy to reason about and read. You've got two approaches when testing this server type. You can call that serve HTTP method, and that's like simulating a real HTTP request coming in. In fact, all the middleware is going to get hit, actually. So if you've got middleware in the roots and everything's ready, and you've got you might have logging, you might have different auth middleware checking, make sure that they've got permission and things. All that's gonna be hit if you call serve HTTP on the server. And that's like an integration test in a way for your server. If you want to do more like a unit test, you can just call the methods directly. Remember, The handlers are just methods now that just take the response writer and the request. So it's pretty easy to just call it as a normal method. And then you're not testing anything else. You're only testing that method itself. So for example, if there was auth, it can be a bit of pain. You've got to authenticate. And if you're doing that a lot in your test code, can get a little bit annoying. So you get to skip all that by just calling the handler directly, which is quite cool. But you can also make real HTTP requests. This is the HTTP test new server function. And you give it the handler that you're interested in, and it gives you back this server object, which after you always defer the close of that object, and then you can use the serve URL and make real HTTP calls to the server. So that's even more real than calling the methods. You're actually dealing in some way with real HTTP, because as you can see, that's the HTTP package there, the get. So that is really it is making a real HTTP call. So it doesn't get more real than that. And there's great benefits to having your tests behave as close as possible to a real life situation. So that's one way to do it. Turns out to be very useful. This is also good if you want to mock out some third-party service. You can just write a little handler, or a handler func even. So it's just a function, and that might be some remote service that you're gonna call something, and you want to just get an OK back from it, let's say, just so that your code doesn't break. You can do things like that with this type, and you just have to make that URL configurable, and it will work. So it's very useful types. They're worth playing with if you haven't seen them. The middleware themselves are also very testable, and you do it again by just creating handlers in your code. So in this case, we just want to see whether that is admin only. You want to see to make sure that only calls the handler if the bearer is correct in this case. So you can do things like this, and you're using the middleware, but you're using it in a different way. You're not passing a real handler. It's a little test handler that you've got, and the test handler's in the test function too. So everything's together. You can see everything you need for this test. It's all in one place. If you compare that to, which is very common, of creating different test types and things that you might be tempted to do, it's completely fine, especially if you're using them all over the place. But it's an extra thing to learn, whereas this isn't. This doesn't contain anything new to learn once you know the basics. So I always say, write boring code. It's more fun when you do something that's really clever, but every time I've done that, I've regretted it. So now I just only try and write really boring code. Have a server struct to hold the dependencies. You avoid global state and make your server very testable, very easy to test. All the routing in the routes go file, one place to see everything, and when you're debugging stuff, you can take it from there. Handlers being anonymous functions returned from methods. So you get that closured environment where you can do extra little things. And use HTTP test for testing and call the methods like you would normal code. It's very easy. These slides, and there's some more bits to this, are on the Pace blog. There's a story there about this. And that's it. So thank you very much, and I will now take your difficult questions.
We had a question in the chat real quick. Sorry, I didn't really interrupt you in time because I didn't read it. Is there a reason for why you would like to include middleware inside the server struct and not as a method inside a separate package?
Okay, so well, generally on that point, yes, there is a reason. In this case, look, the middleware hangs off the server too, so you can access those dependencies. So that's one reason why you might do it. It depends on the wider structure of your application, probably, but I don't really break things down into lots of packages. I tend to have a big package with everything in it, and only when that becomes too much do I then break things out and put them in different places. So yeah, but if you've got a massive system and lots of people, then it probably is a good case for having these middleware in some common package, maybe that everyone can import. That would also be fine too. But if it's something like this that's simple, I would just copy it into my project and not have the dependency, just because that's slightly simpler and in some cases saves a lot of pain. If you end up importing packages, and sometimes you might need something from this other package, and then you have to break them into some other common package, and you get to avoid these import dependence. I mean, the cyclical import problem. You can get that if you break it out too much. So I tend not to do it. Does that answer their question? Well, let's assume it does.
I said yes.
Okay, good. Why is it so dark in here? Look how dark it is. I'm just lit by my monitor. I didn't realize how dark it was. Sorry, it's really creepy. It looks like evil, like an evil presentation, doesn't it? Any other questions? Great.
I think that's it then. Thank you very much.
Thank you.